Thank you everyone for joining us today. My name is Melissa and will be the producer for today's event. Welcome to the 5th Masterclass Series webinar of OMS eLearning Academy. Today's webinar topic is Crude Blending, Part 1, Concepts and Economics. We have an overwhelming response of 75 plus registrations from 30 countries and welcome you all and hope you all will have a very informational and interactive session today. Before we start, let me discuss a few house rules. The webinar will be about 40 to 45 minutes long with 10 minutes for a Q&A session. You can enter your question in the chat box during the presentation and it will be answered at the end of the presentation. Please remember to select everyone when entering your question so we can make sure that your question is read and then answered. The webinar will be recorded and available on the OMS eLearning Academy website. There will be 2 questions at the end of the webinar for your input. They will be poll questions for you to respond to. Please give us your candid feedback at the end via the redirected Google form. Today's webinar speaker is Dr. Suresh Agrawal, the founder and CEO of Offsite Management Systems, LLC, and Academy Director of OMS eLearning Academy. Offsite Management Systems, LLC was founded in 1998 in Houston, Texas. It is chartered to provide consulting and refineries automation projects executions worldwide. OMS eLearning Academy was founded in 2018 to provide continuing education to professionals working in the downstream refining industry and related businesses via the eLearning platform. The Academy has 200 plus courses that can be taken online anytime, anywhere, and on any device. You will learn 3 ideas of crude blending of Part 1 concepts and economics in this webinar. All about crude, concept of crude blending, economics of crude blending. And with this, let me introduce you to our speaker today, Dr. Agrawal, to start the webinar. I'll be back at the end of the presentation to thank you all. Thank you and enjoy your webinar.
Greetings, everybody, and thank you for attending the part 1 of 2 webinar series on crude blending. As we talked about in part 1, we'll talk about concept and economics, and part 2, we'll talk about analyzers and controls. So in this webinar, we'll start giving some background about the crude, qualities, classification, supply sources, how crude prices are affected and estimated by using benchmark crudes, refinery product types based on the crude qualification, and why crude blending is a very attractive alternative to the refiners. How are the crudes transported from source to destination, its pros and cons. We'll talk about concept and modes of crude blending. And most important feature of this webinar, it will show you how can we optimize 2 crude blend and 3 to 4 crude blends using system developed in Excel by our academy. And we'll talk about the modes of crude blending and how the crude blending and product blending are integrated to make sure that we get the right type of crude and we produce the right type of products. So just to give you a background, a typical crude distillation unit, a typical refinery produces about 5,000 plus products, and of those products, 75 to 85% are blended fuels, products like gasoline, diesel, LPG, fuel oil, etc. The quantity and the quality of the stream for the distillation column depends upon the quality of the crude oil. And they propagate downstream to other process unit in terms of the finally product qualities which are used for blending. Usually refinery is designed to operate on a certain type of crude. Over the years, it was okay, but now that particular type of crude that the refinery were designed on is not available, or if it's available, it's very expensive. So the supply of consistent quality of crude is becoming less and less and becoming expensive. Before we go on, let's look at the qualities of crudes and its refining impact. Here are 7 qualities of the crude oil. Density, which is measured in terms of API. And if a higher the density, higher the API or lighter crude processes more of light end products, where the low API or heavy crude produces more of residues. Then sulfur varies from 0 to 4%. And that causes a problem in the refining process. To process the sulfur, it requires additional processing and in the units, as it causes the corrosion, fouling, and catalyst poisoning. 10, total acidic number is also causes a problem in terms of equipment corrosion and severe problem with product quality. Then basic sediment and water, which is termed as BS&W, which is 1 to 3%. It also affects the desalting effectiveness, increasing fouling and corrosion risk in downstream units. Then the cut points. Based on the light or heavy crude, the cut points are differ. And when they are different, then they also affect the quality and quantity of product based on the crude oil quality. Last 2 quality, viscosity and pour point, are important for the transportation of crude via pipeline. If it is very viscous, like a heavy oil, it becomes very difficult to pump through pipelines, uses horsepower. And if the pour point is too low, it also becomes a problem to transport through pipelines. And we'll talk about this property a little bit more in detail and what refineries or industry does to alleviate those problems. Just to classify the crude is classified in 2 properties, API, of which is density, and sulfur. So the light crude are greater than 31.1, medium between 22.3 and 31. Heavy is less API, and extra heavy is less than 10. For sulfur, it's called sweet crude if the sulfur content is less than 0.5%, and sour crude if the content is more than 0.5%. So now we understand how the crudes are classified in terms of API and sulfur content. If you look at the worldwide classification of crude supply, you can see the pattern is scattered all over the map. Sour heavy, sour light, sour sweet heavy, and sweet light. And you can see that the sources of sweet light are more clustered on the right side, and sour heavy is on the left. Now, it might indicate to you that maybe we have a lot of resources and supply available for sweet light. It's not so, and that is why it's causing a problem for the refineries to meet the quality of their crude supply. In terms of pricing, if this is a heavy crude, it's cheap, and if it is a light crude, the sweet is expensive. So the cheap crude are also called opportunity crude, where refineries can use those heavy crude and heavy sour to process in the refineries and make profit out of that. And we'll see that concept as we go more in this webinar. So most of the refineries resort to blending of 2 or more crudes to get the crude quality for the refineries. Now, in terms of supply of crude types in the world, you can see that the Middle East has about 49%, and Western Europe has 20%, Africa and Canada 10%. This is, even though a little bit outdated graph, but you can see the idea and get the appreciation that the different types of crude are available worldwide in different regions. So what does really matter, whether you have a light crude or heavy crude? It matters because it governs what type of products can be produced in the refinery and what they can be used for. If it's a light sweet crude, which is greater than 34% API and less than 0.7% sulfur, it is more expensive and it has a 35% demand, and it produces more of equal of gasoline and distillate, like 30 to 33%, and less of heavy oil, 35%. So if you take a medium sour crude, it produces different proportions of the products, and heavy sour is more of a residue, producing less of light products. But also it's least expensive, and sometimes they are, as I said before, are termed as opportunity crude for the refiners and the traders. So refinery faces challenges because of the ever-changing crude feedstocks. But at the same time, the good news is that more and more sources are found as they adjusted. New pipelines are built, ports are open, and import or export restrictions are lifted to facilitate the supply of crude to the refineries. Also, discounted crudes offer cost advantage, but you have to weigh them buying a cheaper crude versus increased processing in the refinery. And this is, we're talking about both heavy crude and also the sour crude. And we'll see more of impact as we go along. So if you know, in the industry, there are two types of crude used for a benchmarking for the prices. One is called WTI, which is Texas, Western Texas Index, and Brent crude. Now, WTI is mostly US-based crude from the oil fields, US oil fields, and Brent crude is the benchmark used for Europe, Africa, and the Middle East, and they are originating from North Sea between the Shetland Islands and the Norway. Now, as we guess, the crude is more expensive than WTI. It is from more of a dozen or more oil fields in North Sea. But the price differential between Brent and WTI crude is between $6 to $10. But at times, it can spike up to $20 based on many political, geographical, and world conditions. And you can see the discounted or opportunity crudes can go up to 20-25% discounted if it is a medium sour or heavy sour crude versus using the WTI or light sweet crude. So the refinery have an opportunity and also flexibility to meet the crude design spec for the refineries, for the crude distillation columns. Now, how is the crude transported from the source to destination? There are many modes, and each mode have a pros and cons. Most common is the pipeline. Then comes the oil tankers, the barges, tugboats, rail wagons, and trucks. Now, you will see next that pipeline is the most preferred method of crude transportation, and it is least expensive on the per barrel cost, and also it delivers to refinery at large. However, it encounters pumping costs due to long distance and viscosity, and it has to have a intermediate pumping station, a heating station, to facilitate smooth flow. Oil tankers are large. They can carry very large volume of crude across oceans, but delivery time is slower than the pipeline for obvious reason. It has a risk of oil leaks in the ocean due to accidents, and it has a high demurrage cost to the refineries if they are not loaded in time due to unavailability of a tank or whatever reason. Barges and tugboats are smaller in volume, and they are used mostly in rivers and canals. They require less infrastructure than pipelines, but they are more costly to transport because of the less volume, and they take more time to load and unload. Rail wagons is becoming popular lately. It's getting alternates to pipelines and gaining popularity. It's expensive than pipeline, but economical where pipelines cannot reach to refinery or meet the capacity. So it's getting popularity in the world, mostly because of the infrastructure is more than the pipeline. Trucks are the most expensive and most riskiest because of they carry the less volume to transport, and they are only suitable for short distances and small volumes. And they have a susceptibility to accidents, risk, hazard on the road. So if you compare the modes of crude transportation, you can see the pipeline is still the prominent mode of transportation. Then comes the waterborne vessels, ships, barges, tugboats, rail cars, and trucks. Trucks are a small quantity or a small mode of transportation. And each of these mode has a feature for time-wise availability, transport volume, and inherent accident, spills, and leakage risk. But by looking at the graph, we can guess that pipeline and ocean vessels are the most two important mode of transportation of crude oil to the refineries. Now, let's talk about pumping heavy crude oil. It's very expensive because of the viscosity and the pour point. And it is expensive for the trader or marketer as well as the refineries because they get not in time. So what are our options? What do we reduce the viscosity and pour point of heavy crude through pipelines? One of the methods is it mixes with the light crude, which has advantage also and is a profitable in terms of crude blending. But also it requires a balancing between the cost saving from crude supply and additional processing cost of sulfur. Second method is emulsification. The traders or marketers add water, other chemicals can lower the viscosity by plus 90% plus. It lowers the value of crude and requires removal of water before crude processing. So refineries don't want to pay value of crude for the water. So they have to either discount it or process additionally to remove the water from the crude. Third method is they use drag reducing agents, DRA. They are a small amount of polymer and surfactant, and you can decrease the pressure drops and facilitated pumping. But it also requires very careful selection because it can require some effect on the end processing, especially jet fuels. Fourth method is to install heating and station along pipelines. It reduces the viscosity and increases the crude temperature above its pour point to help pumping. It's expensive, it requires controls and installation of many heaters along the pipeline. So the crude blending has three parts: the crude blending by itself, the crude unit control, and the product blending. And these all play an important role in its own place. The crude blending feeds designed crude to the crude unit control, which controls the processing of side streams of quality and quantity, and in passage to product blending. The product blending, you make fuels, which is 75 to 80% of the end products. And it affects the profitability of the refineries. So we have gathered that the crude blending offers consistent crude qualities. It removes the minimization it minimizes the dependency on crude feed quality for stable optimum operations. It maximizes product yields and quality. It improves crude oil inventory for just-in-time manufacturing and reduces the damage by better planning. It has two stages. Stage one, the crude blending is done at the port from a pipeline to tanks in the refinery. And stage two blending is done from tanks to the crude feed tanks. And we'll see more of these things, how this two-stage crude blending is done in the refinery and what are their benefits. So different types of crude blending configurations are practiced in the refineries and the industry. First, we do pipeline to tanks, and it can have a multiple blending systems, or it can have one blending system which can control different crudes going to different tanks based on the composition and requirement. The second comes to ship to tank directly. It has some limitations because if the ship is waiting too long at the port, refinery will pay the demurrage charges. The third mode is tank to tanks, which is done in the refinery itself. Then we have a multi-header blender to feed tanks, and then feed tanks to units. Now, stage one blending, as I said before, is done from source to on-premises tanks. In stage two, is done from crude tanks to crude unit feed tanks. And some of these modes are more in the industry and the particular site of refineries, and some are less, but they are practiced more or less. So how do we optimize crude? Now, there are two modes. We can blend two crudes, binary crudes, to two qualities, API and sulfur, and it generates a deterministic recipe. It can be blended at the marketer's blending facility or blender skid at the refinery site. And you see the picture of a blender skid, which can be installed at either of the places. Now, blending objective is to minimize the deviation from the desired crude quality spec, and then the profit is calculated. I want to remind you that this is a little bit different than the product blending. If you have attended my previous webinars on product blending, in a product blending, we maximize the profit and minimize the giveaways. But in crude blending, we minimize the deviation from the quality of the crude, the sulfur and API. If it is more than two crudes, we're still optimizing the API and sulfur, but it requires either LP optimization due to less degree of freedom, because we are blending 4 crudes or more to 2 qualities. So it has a less degree of freedom. So it has to use a different mathematical technique. Most of the time, they're blended at site from tank to tank or pipe tanks blending strategy. So inline blending or tank to tank blending, there are 2 modes. So inline blending is less costly than tank blending, both in capital and operating and maintenance, because they are supplied by the manufacturer or the skid manufacturer as a package which can be installed. It has controls and everything, and we'll talk about it in the next webinar. The crude residence time scale is minutes. Feed can be altered in a short time frame, automated through control loops and online analytical instrumentation. Should the incoming fruit quality have quality variability, then the real-time adjustment capability. Online analysis is completely representative. It measures the quality of the incoming crude and the blended crude. And the skid has a small footprint. On the other hand, tank blending requires efforts because the tanks are expensive to build. It requires operation of pumps, agitators, utility expenses, maintenance. It has a long blend time, difficult representative sampling, lab analysis is not immediate. Correcting off-spec blend requires considerable rework. Blend incompatibility leads to precipitation and fouling, and tank cleaning is labor intensive and expensive. One of the drawbacks of this tank blending is because of keeping the uniformity of the crude in the tank. So they require a circulation or the mixer in the tank. This is a multi-header crude blending where from the pipeline, they blend into 5 crude feed tanks, and it requires a optimizer ratio controller. So in terms of control instrumentations and pumps and control valves, this is more elaborate and complex scenarios. But this is perfectly feasible, as I did for one of the refineries in South and Latin America. So the crude blend control optimization is a 3-part. The first part is movement planner and scheduler. The refinery planner or enterprise planner plans the supply of crude. And once the crude arrives at the port, then they have to do the movement from the ship to the tanks. And that second part is movement tasks, monitor and control. And third party to calculate and estimate the composition of the different types of crude in the tank and monitor, and that leads to monitoring and control to feed to the crude units. So each crude blending system requires three parts of automation. Now, how are the crude prices estimated? This is not a fixed price, this is a dynamic market. Based on the supply, based on the political situation, based on war in the world, you may call it. But the good news is that they are benchmarked using two types of crude, Brent and WTI. And all other crudes are calculated differential from there. And though the differentials are based on API, sulfur content, not only those, but also depends on supply and demand and movement of those type of crude in the world. This table can be programmed dynamically as you require to show the price differential from Brent benchmark crude oil. So you can expand the table to include as many crudes that your refinery handles. And we'll talk about more of this as we go along. So if typical spec of crude oil pipeline is a minimum maximum spec of API based on what refinery orders. It can have virgin sweet, medium sour, heavy sweet, and LS condensation. And basically it has an API and sulfur, but sometimes it's also specify other like a 10. So API, sulfur, and 10, which is a total acidity index number to supply the crude via pipeline to the refinery. Now, if the marketer or trader has a facility to do the blending, it is more profitable for the trader or marketer. And if the refinery does at their side, then they have the cost savings for the crude. Now, how do we optimize a crude blending recipe? Now, there are two methods. One method is a binary crude blending, which is a two crude, and it's a simple to optimize it. Like you take one crude ratio and vary it until you reach the RMS, which is least square of error or differential between the spec and the crude quality, final crude quality. And this is very quick, very simple, and requires only one execution. Now, multi-crude blending is more complex than the binary crude. There are many mathematical methods to do that. One of the methods is like nonlinear programming or action solver. But one of the difficult of those methods are that any point they give you the optimum solution, you really don't know whether it's really a global optimum or it's a local optimum. I mean, you assume it's a global optimum, but you don't know. There is no visual way of knowing that. In a method that we'll discuss in this one, it will show you the global optimum is true or not. Now, basically, method is based on like a dartboard. You have a dartboard and you are given a set of darts to throw at the dartboard. And out of 100 cases, 100 tries, you might miss 98, 97, but 2 or 3, you might come very close to the bullseye. And that becomes your global optimum. And you will see it in a few minutes. So in terms of two crude blending formulation, it's very simple. It's not completely linear because the API and density are not related in a linear model. And also the sulfur also depends upon the density, which is also depends on API. So it becomes a sort of a semi-linear model. So we cannot use a calculator to calculate the recipe if we do it for two component, two qualities mixture. So what are your objective function is? Our objective function is to minimize the deviation between the API spec and API or blend for the API and sulfur. And if we reach the minimum, that's a global optimum. So on the right-hand side, you can see that the optimum two crude blending has reached in about 500 iteration. And this iteration takes less than 5 or 10 seconds in Excel. And you will see it in a demo that I'll show you. So we start with this 2 crude. And these equations are also be used for other types of crude, 2, 3 crudes or 4 crudes. So we have developed a Excel-based calculator or optimizer for 2 crudes and multi-crudes. Now, here, all the crudes are included on the right side table with their price differential and their properties. And you can expand this table to as many crudes that you want. Now, we can select the crude by using the index 15 or 28. The index 15, 28 are the crude types. And once you select that one and get the crude blend ratio, it will calculate in iterative mode and comes up with the global optimum ratio for 2 crudes. It's a very simple calculation, but it's very powerful. Let me show you a demo of how this is done. This is a demo of how we can use Excel calculator using custom coding to optimize 2 crude blending ratios. So the basic input is list of all the crudes that you see on the right-hand side in the table, which you can expand, update it as per your requirement or as per your site. And once you're done that, then you can select any 2 crudes from the table. Now I'm keeping a light sweet WTI as a base, and I'm mixing crudes to see the ratio. And let's see if I select here the crude number 24, which is sweat blend, and I put it, get the ratio. Now it will get all the data from the right side table and optimize the ratio. You can see the calculation are progressing. It's calculating the profit, API of the blended crude, and the sulfur content. And it takes only a few seconds, less than 30 seconds, to come up with the final optimum recipe. And it shows the RMS, which is least square error, is shown at the bottom. And based on the lowest minimum, it shows the final crude API, the sulfur content, and the cost, and the profit per year basis for 100,000 barrels per day refinery. Now, so we can run different combinations of binary crudes from the table and run the optimizer. And for those crudes, it will tell you the profit and the recipe and the RMS. And based on that, the refinery or the trader can select the combination of binary crudes. Now, we don't meet the sulfur spec, as you can see on this table. Refinery needs 0.4, but it meets the spec for the API. So this is the trade-off between the money saved from the crude blending of heavy sour or light sour crude, and versus the processing of additional sulfur in the refinery. Now let's talk about multi-crude blending from 3 to 4. Now this example, I have taken 3 crudes, again keeping WTI as the base case, and I can select any two additional crudes. Now the technique here is that it's like you're given a set of 5 darts to throw at the dartboard, and you are given 20 times the chances. So in other words, you are given 100 chances to throw dart at the dartboard, and you're hoping that one of those darts will hit the bullseye or close to bullseye to give you a global optimum. The way we do it, that we use a seed generator to initialize the initial recipe, normalize it, and calculate the RMS for that one. And we continue this number of iteration. So let's see, this is the demo of multi-crude blending. We're going to see how we can optimize the multi-crude blending for 3 crudes or 4 crudes using a different technique, binary crude blending. In the previous video, I've shown that the binary crude blending is much easier in iterative calculation by using the ratio of one component, normalizing it, calculating the composition of other component, and reach the global optimum. We cannot do the same technique for multi-crude, more than 2 crudes, 3 or 4, or maybe more. So we have to use a technique called random seed generator for a initial recipe. And the technique is like playing on the dart board, where you get a multiple number of chances to throw dart to hit the bullseye. So on here, you are given, for example, you are given 20 chances to throw dart at the board, and each time you are given a set of 5 darts. Every time when you throw a dart at the board, the recipe is generated using a seed generator. And the root mean square error is calculated to come up with the recipe for the API and the sulfur. Now, so this is a 100 iteration, and that 100 iteration has taken less than 60 seconds, less than a minute. So the technique is pretty fast, and it gives a truly global optimum value, as you will see further. Now, I'm not going to run this optimizer, but as I already have run before, and I'm going to show you the results of these 100 throws of the darts. So these are the cases which are shown for cases of 5 darts throwing and up to 100 times. And at the 19th throw of 5, it hit the global optimum, and it shows the lowest RMS of the spec, and it meets the spec of 37 and 0.8. It's not going to meet 0.8, 0.4 spec because it's almost impossible, but it is becomes the opportunity crude, where you buy the crude at a high sulfur and make the profit of $37 million per year. And that had to be balanced against the processing of additional sulfur in the crude. We're going to see how we can optimize the multi-crudes blending. Okay, so you've seen the video. Now, to re-summarize this one, now on the right-hand side, you see the iterations and the RMS. Now, this gives you 2 pictures, whether it's a global optimum or a local optimum, which in terms of a minimum RMS. Now, this, you need to see this one every time we run any optimizer by any software. This information is not generated, they become like a black box. But this technique, it'll show you where we really have reached the global optimum or not. If you're not sure, we can still run 100 more cases on the top of it, and it will go further, and it will confirm whether you're reaching a global optimum or not. And once it reaches a global optimum, then the recipe is generated and gives you the profit, which is $37.5 million per year, 100,000 barrels per refinery. So I'll give you an example of 4 crudes blending, and you can run the same crude blending in terms of optimizing 4 recipes, recipe for the 4 crude blending using the same calculator or same technique. Now, the functions of crude blending we have said before, but it has a planning and scheduling system on the enterprise level to evaluate different crude types and maintain supply And different crude types can be evaluated using the optimizer that we have built. Crude blending can be done at the terminals or within premises. We need a crude quality and composition monitoring system. And also the crude feed quality control and optimization of the crude unit. I'm not going to talk about the optimization of the crude unit because that's not a part of this scope of this webinar. So in the end, we do need integration between the crude blending and the product blending. And it's a feed forward and feedback integration. Whatever product quality are needed for the refinery long term, they also control what type of crude refinery need to order and how the crude units are operated and optimized and controlled. So in summary, crude blending is becoming an accepted alternative to stabilized crude unit operation due to variation in crude supply sources. It offers refinery leverage to buy crude from different sources to increase the profit margin. Crude blending is similar to implement the product blending because of semi-linear models. Excel-based optimizer can be used very effectively to evaluate different types of crude, different combination of 2 to 3 or 4 crudes to come up with a recipe which they can be used in their refineries. That concludes my webinar.